Thank you very much for the introduction. My name is Thomas Dasbach. Me and my colleagues, Sebastian Friedl, will in the next 20 or so minutes bring you a small presentation regarding using OPCUA companion specification for a type-based client application, basically showing you why OPCUA companion specification are a very neat thing if you try to integrate multiple machines of multiple vendors, but you have companion specification defining the interface. Let's start with a very brief introduction. My name is, as mentioned, Thomas Dasbach. I'm working for the VDMA, and to be more precise, for the Department of Machine Information Interoperability, where we address topics like OPCUA and especially OPCUA companion specification, meaning we here in the VDMA have over 70 working groups that are working on companion specification. My role, to be exact, is I'm team lead for research and modeling expert for OPCUA. And Sebastian Friedl, he is head of the department at Interop4X, a small software company that is developing interoperability solutions for the shop floor, and therefore also working on OPCUA companion specification, or to be more precise, implementation of companion specification within machines or software environments. Okay, first let's start with the question why we actually want to use OPCUA companion specification in the first place. What are the advantages? There are multiple advantages of OPCUA companion specification, but mainly interesting for us or for our members in this case is that the integration gets much shorter of new machines in existing shop floors, or vice versa, if I want to integrate a new software solution within my shop floor. And let me explain why. If we have two examples here, in both cases we are already using OPCUA on the transportation layer, so that we have the connectivity mechanisms of OPCUA. On the left side here we have two devices from two vendors, and each vendor has its own model on its device. This means that if I want to integrate both of those machines and connect them to my software solution, for each device I have to tell my software solution which data point means what. To give an example, if I have the identification, OPCUA vendor A may use the identification as modeled in the DI specification, but vendor B may have modeled his complete separate model, giving the ID as a string, for example. And then I have to define in my software solution that those two information types are the same. But on the other side, if I have companion specification and the semantics are standardized, I have the advantage that each device uses the same basic model, meaning the cost for adaptation get reduced because I only have to program my software solution against this specific companion specification. For example, I could use the OPCUA for machinery if we are talking about identification, and if all devices then use the machinery specification for the identification part, then I only have to program this once, and even if I put now here 3, 4, 5 additional devices into it, I don't have more integration effort. And of course, just to complete this, I can also each vendor can then extend the model on its own to provide additional information, but the basic model is the same, and that's the big advantage of companion specifications. A platform where we show how beneficial OPCUA companion specification are is UMATI. UMATI is an initiative, and to explain why we need it, we have to acknowledge that the VDMA is an association mainly for machine and components builders, and not so much of the users, or for the users of those machines. And therefore we needed some kind of platform where we can bring those two parties together, users as well as machine builders, because both are very important stakeholders if we are talking about companion specification for certain machine types. Because the user might have other ideas or use cases in mind for companion specification than the machine builders. And what we are doing in UMATI is we are exchanging, for example, best practices between those two parties. We are exchanging lessons learned from first implementation of companion specification. but also we show by a joint proof of functionality that the companion specification works as intended. And we do this by usually by bringing users and machine builders of a domain together. They both implement the companion specification on their side, so on the client side and server side, and then the systems work together to show that the companion specification actually enables the use cases the companion specification set out to solve. Such a functionality showcase is usually combined with a fair participation of the machine builders, meaning that they select one big fair for their specific domain and ship all their machines that are OPC companion specification enabled to that specific fair. They put a UMATI sticker on the machine, and the reason for the UMATI sticker is mainly the QR code, and the QR code leads you to the website umati.app. And on umati.app, there's the dashboard application running from Umati. This dashboard application, I will show it in a second, but what it actually does is it connects to all the machines on the fair, extracts the data that is provided by the OPC companion specification, and shows all data independently who the vendor of the machine is in one standardized way. So you have a very easy way to show interoperability and show that the data is actually modeled in the same way. And this is basically how umati.app looks if you first connect to the web page. What you can see here is an overview of all the machines and their location that have been connected recently to Umati or are currently connected to Umati. And now what I've mentioned, if you have a fair, then all the machines also are displayed in this overview here. And the neat part, basically what my colleague will demonstrate in a second, is that you can open any machine here, and you see all the information that is provided by OPC companion specification in one standardized way. So for example, up here you get all the information that is provided by the OPC for machinery companion specification, and down here in this specific case we have the geometrical measurement system companion specification, the information here and parts of this down here is provided by the companion specification of GMS. And the neat part is that you only have to configure the dashboard once, and independently on how many GMS machines you connect from which vendor, the information can be extracted each time in the same way.
To demonstrate how simple it is to integrate new machines to the Umati dashboard, we will now show you an example from the mining sector. The companion specification here includes object types for the haulage machine. This includes basic building block from the mining for the identification containing the attributes like the asset ID, manufacturer, or the serial number, and also here our parameter set, which contains the current payload and these attributes from the identification and the current payload should be used for our Umati dashboard demonstration. Let's first look at an example of its VAR server that has implemented specification. Here we see a machines folder from the machinery type, and there is our my truck, which implements the haulage machine type. This contains here our machine equipment identification, which is the basic building block for machinery. This, for example, the asset ID, in our case here a German nameplate, the manufacturer ID and the model. And also in the parameter set, we have here the current payload with a changing value with a simulation behind it. And if you look at here on a graph view, you will see that the value increase after time or decrease. So there is a small simulation behind the current payload and the speed. To integrate the compare specification, we need to do two things. First, we must configure how the data will be displayed. Therefore, we create a template based on a common display elements like a text block or some gauge graph. This is a one-time effort per compare specification and only needs to be done at the beginning. If the configuration is done, the machines can be connected. This is a simple step and can be done very fast. We used a gateway to receive the data from the OPCDI server and make it available via MQTT. The gateway is the only part which needs to be configured for the connection of a new machine, and Thomas will demonstrate this later. The data is forwarded via the MQTT broker and the dashboard server to the dashboard client, so the web browsers. Also, the dashboard server gets the templates from a storage and provides them also to the dashboard client. And there, the dashboard clients can put the data into the template and display the description of the machine. Now we begin with the actual creation of the templates. We start the configuration by uploading the node sets of the specification which are used. In our case, we have for specification, we want to use the device integration machinery for the identification part, and then for the domain specific parts, the machine mining in a general way and the mining with the transport specific information. If they are uploaded to the configurator, we can now check if the integration and import was correct. And if this is also done in the next step, we can then select the Hawk machine type as our main entry point in the configuration. Now, after the selection of the type, we can select here our start the configuration and create our template. And here we see two points of the header, the name and the model. And this is the part we've seen here before. For the name, we select asset ID, which is the smaller part here in our video. And the model is the bigger one. And therefore also use the model of the device integration. So there's two properties seen here, which is not basic GMS, is now afterwards should be our asset ID or model. The other two points here with image, stack lights and timeline are not implemented in our specification and used. So we can skip this point and start creating a new section. This is the first level for the modeling. And this section here becomes a name for the identification from us, and now we can add a row and then the text elements, for example. Each element can have an individual label and then has the value. We start with the manufacturer and then also the text label text for the product instance URI, select our value, also map the identification here. And in a third step, we also do this with the serial number. So here we see the advantage with the label. So the serial number here is separated, but the browse name is written together. After this, we also had our parameters. Want to create a section for the parameters, which we call parameter. Add also here a row, and now we want to add two examples for the current payload to display. The first is we select also the text element, then the value will be printed as a string on the template here. For example, we select now, also make the mapping of the current payload again, and then we want also add a second element, and this should not be a text element, so we remove it. It should be a char element. This char element also get the same label. We select also the value of the variable, and then this is the interesting part. We can say give a range. We know this value will be between 0 and 5, so we can add this at this point. So this is our very simple template. This can be increased with all data we need, and then we can download this file, upload it in our dashboard, and now the machines can be integrated into the dashboard. And how this works, Thomas will you show in the next slides.
Thank you very much. Okay, what we have seen now is that the dashboard configurator has been run, and we have a successful template for our dashboard. And what we are missing now is we have to get the data from the OPCUA server through this client that's based on companion specification into the dashboard. The client application that we provide is a gateway application. It's provided as an open source implementation and a Docker container on GitHub. And the only thing that now a company has to do once it has downloaded the gateway is they have to open the configuration file, and in the configuration file they have to put in the endpoint of the OPCUA server. And in obviously any reasonable OPCUA implementation, we have no security in this demonstrator, so nothing up there. And then we have to also put in the MQTT endpoint of the dashboard, where the data from the OPCUA server gets funneled into by the gateway client. Putting in the username and password, obviously. And then the only other thing that we have to do is to Docker compose. So starting the Docker container and defining which configuration it has to use. And then we press start, the configuration starts, and we don't watch now the entire Docker container spinning up, but jump to the part where the data actually gets into the dashboard. What we now see here is on the left side, we have the web front end of the dashboard application, basically showing all the machines that have been connected in the recent past or are currently connected to the Marty dashboard. Top right, we see the sample server that it's running in the background, and the bottom right, we see the spun up Docker container. So basically what we can do in the dashboard, we can search for machines, and here's the sample truck that Sebastian just has modeled. We see the identification provided by the OPCUA for machinery, the few parts that are modeled in the sample server, and we see the current payload, the one information that Sebastian selected in his template. And as you can see, if now here exactly there, the current payload now changes, the gateway client pushes the data to the dashboard application, and the dashboard application continuously shows the changes. And that's basically the easy part. Sebastian did the template configuration once. I set up the configuration for the gateway client once, and the gateway client is programmed against companion specifications. And that's basically how easily you can connect now new machines to this environment just because the machine in the modeling of its interface is using companion specification. And that's it already. Thank you for your attention. I hope this little presentation was informative and has shown you the benefits of OPCUA companion specification, and in this particular case, a client based on those companion specification a little bit more. And in case you have any questions, feel free to ask. Sebastian and myself will be here in the chat and answering all your questions that you might have. Thank you very much.